So again, we've talked about three methods for solving. We've talked about graphing, substitution, and elimination. So what am I going to get if I try to graph an equation with three variables? What kind of shape is my graph going to give me? A triangle is not a terrible answer, but it's not the right one. It's not quite a square either. It's a plane. So if you graph in two variables, you're going to get a curve, something that's two-dimensional. If you graph in three variables, you're going to get something in three dimensions, so like a plane. So like a planar figure is not a terrible answer. So here you're looking for the intersection of three planes. And this all gets very difficult to kind of construct visually. We're not going to approach these problems from a graphical perspective. Okay? It can be done. It's very messy, and it's usually really difficult to figure out from your picture what the intersection actually is. So we're not going to be so interested in this. Okay? The next method we talked about is substitution. Substitution gets rather long and pretty confusing because there's a lot of bookkeeping to take care of. Things really end up getting worse before they get better. I'm not going to even bother to try to show us how to do substitution on these. I'm not really interested in doing it because it's not a terribly efficient method when we have three variables like this. We're going to focus solely on elimination. And elimination, things tend to get better as you go through it because each time you do an elimination, things get a little bit simpler, right? So the general idea here is we're going to start off with three equations and three variables. We're going to perform two eliminations, and that's going to give me two equations with two variables. That's going to be basically just like last night's homework. So there, we're going to do one elimination, which results in one equation and one variable. Which we can solve to get one part of our answer. What I do then is I take that answer and I plug it back into the two variables and two equations situation. That's going to get us the second part for our answer. And I take both of those answers and plug it into one of the three variable equations. And that'll give us our third part of our answer. It looks bad. It's not as bad as it looks, though. Before I started doing any of this, though, I wanted to give you guys a visual to kind of describe what this process looks like and what it is that we're doing. Well, because you're going to have X, Y, Z, right? You're going to have three parts to your answer. So, again, as you're working on these, especially if this is like one of the first times you're trying to do a problem like this, it's often going to be helpful to be looking at this process while you're doing the problem and think about where you're at in the process. It's easy to kind of get lost because it is kind of a lengthy process. But if you keep in mind of where you're at and where you're trying to go, it often is helpful. Okay? So let's return to this problem here. So to do that first step of doing two eliminations, what I like to do is I like to pick one equation that I'm going to use as my eliminator equation. Basically, what I'm looking for to make this process as easy as possible is I'm looking for an equation that has at least one variable whose coefficient is 1 or negative 1. Looking at my options here, I would use equation C because I noticed that the y has a coefficient of 1 or negative 1. The next best option would be finding an equation, if you have no coefficients of 1, is to use the equation that has a variable that divides the coefficient of the other two variables. So if I didn't have a leading coefficient of 1, picking equation B would be a good choice because I noticed that the 2 divides both 4 and 6. That would be my second choice. Do I need to choose equations in this fashion? No. Why would I do it this way? It makes life easier. You are on fire today. Good job. Okay. So, what I'm going to do now is I'm going to use equation C to eliminate the y's from equation A, and then use it again to eliminate the y's from equation B. What do I need to multiply equation C by to eliminate the y's from equation A? Two, right? If I multiply equation C by 2, it's going to turn into negative 2y, and when I add it to positive 2y, that will cancel out. Everybody can see that, I hope. Yes, Clayton. Of course. What would I need to multiply equation C by to eliminate the y's from equation B? That's not a number. Close. I would use negative 3. Right. Everybody okay with why I made those choices? Now, important point here, notice that in each of these eliminations, I eliminated the same variable, right? I eliminated the y's when I added C and A, and then I eliminated the y's when I added C and B. You cannot eliminate different variables in this step. Has to be the same variable with each of your eliminations. Okay. So let's go ahead and write down what we have now. So 12x plus 4x is 16. Negative 2y plus positive 2y gives me nothing. 8z plus 3z is 11z. And negative 2 plus 1 is negative 1. And then if I multiply equation C by negative 3, I get negative 18x plus 3y minus 12z equals positive 3. And 2x minus 3y is minus 18. And again, I'm going to add down. Negative 18x plus 2x gives me negative 16x. 3y minus 3y is nothing. Negative 12z plus 5z is negative 7z. And then 3 minus 14 is negative 11. I'm going to refer to this first equation as equation D, and the second equation as equation E. I'm going to take those two equations together and make my two-variable system. So if I go back to my flow chart, where am I at right now? I'm now on this part, right? I now have two equations with two variables. That first step is the longest step. All right? What we have to do now is another elimination. Which variable should I eliminate here, x or z? Definitely x, right? Why? Because they're already ready to eliminate. I don't have to do anything. I'm just going to add the two equations together. Is that always going to happen? No, we just got lucky this time. So when I do that, I get 4z equals negative 12. Where are we at now in our flow chart? We're one equation with one variable, right? So if we divide by by positive 4, we get negative 3. That's our first answer. So we are now here. What I do then is I'm going to plug that answer back into either D or E. Does it matter which one I choose? No way, Jose. For the sake of argument, let's just plug it into D. So 11 times negative 3 is negative 33. And if I add 33 to both sides, I get 32. And when I divide both sides by 16, I get positive 2. Okay? We have just one more answer to get. How am I going to get that third answer? I need to plug it into one of the three variable equations at the very beginning. Does it matter which of the three I choose? No. For the sake of argument, I'm going to plug it into C. You know, I just picked C because the y was already had a coefficient of 1. So 12 minus y minus 12 equals negative 1. The 12 and negative 12 add to give me 0. And when I divide both sides by 1, I get y equals 1. So my answer then is the tuple 2, 1, negative 1. Tuple. Yeah, that's what I meant. Of course. So what did we notice about this process? Well, after that first step, once we get to the two equations and two variables, it was pretty quick after that, right? Everything after that was pretty easy. The first step is the hard one. If you can get through that first step, things go pretty quickly after that. Let's do another example, though. But of course, which variable seems like the easiest one to eliminate first? I would do z's. And which of the three equations would I use as my eliminator equation? I'd use b as my eliminator because when I add b to either a or c, the z's will automatically eliminate. I don't have to multiply anything by anything, right? That's pretty nice. So we're just going to do a plus b and also b plus c. So, because we didn't multiply anything by anything, I'm going to just write down my results below. Everybody's okay with that? Seemed like no use to recopy them, right? Everybody's good? Okay, we're done with step one. Didn't that feel so fast? So these are my equations, D and E. Okay, what variable do you want to eliminate now? Sure, they're about the same. What do I have to do to eliminate x's? Negative 2 times equation D plus equation E, right? That's negative 4x minus 4y equals negative 16. When I do that, everything cancels out on both sides. What does this mean? Well, it doesn't mean anything is possible. It means we have infinitely many solutions. But that doesn't mean any combination of x, y, and z is going to be an answer. It just means that I do have an infinite number of answers. How do I describe those answers? What I'm going to do is I'm going to go back to one of these two variable problems, and I'm going to solve it in terms of either, in this case, x or y. It doesn't really matter which one I choose. I could get a slightly different answer depending on which one I choose, but all the answers would be equivalent, so it would be fine regardless of which one I decide to get by itself. So let's say I try to get the x by itself. So I'll subtract 2y from both sides, and then divide both sides by 4. Okay with that? So this is going to tell me sum of my answer. So I know x is equal to 4 minus y. So then the x component, I'm going to write 4 minus y. Because y is like our independent variable, the y component, I'm just going to write y because x is described in terms of y, so y is just going to be itself. To find z now, I'm going to take this and make a substitution in either x, or make a substitution into either equation A, B, or C. Does it matter which one I choose to use? No. Just for the sake of argument, I'm going to do it into equation A. Okay with that? So when I do that and combine my like terms, I have a minus z and a plus z. Those are going to add to give me 0. And when I subtract 4 from both sides, I get 0. So the z is 0. Just to let you know, that z could also be in terms of y. It could be an expression of y as well. So, what this tells me is a way to generate those infinitely many solutions. Basically, you can pick a number for y, and that'll allow me to tell you a solution. So, for example, if we say y equals 1, 4 minus 1 is 3, 1, and then 0. That's one of those infinitely many solutions. Right? And because you have infinitely many choices for this y, we can get infinitely many solutions out of this. But if I picked like 10, 16, and 5, that's not an answer. Right? Because it's not in this form. Does that make sense, you guys? I'm going to write up a system here, and I'm going to ask you guys to try to solve this one on your own right now. Just in your notes is fine. You don't need like a separate sheet of paper. We're not going to turn this in or anything. I just want you guys to try doing it on your own. We'll give you, I don't know, 10 minutes or so, and then we'll kind of go through it. So just go as far as you can. If you have to stop and ask some questions, that's okay. If you don't finish before I call time and start to go through it, that's okay. And I'm even going to write up the answer with it, just so if you get that far, you can kind of check as you go, so you don't end up doing the whole thing, only to realize, like, oh no, I didn't get the right value for the first variable, so everything after that is instead going to be wrong. Michael? So my z's have bars on them. So like this is a 2, that's a z. If I don't put the bar there, my 2's and z's look exactly the same. Okay. And then this is a 7. So 3x plus y minus 2z equals 10. 6x minus 2y plus z equals 2, or negative 2, excuse me. And then x plus 4y plus 3z equals 7. Does that feel okay, deciphering my symbols there? Yeah. Okay, and in general, if you have a question about, like, what is that symbol, like, you should ask. It's important that you guys know what it is I'm writing. It's okay, I'm unoffended by, if you're unable to read my penmanship, I know it's not always fantastic. right. Which variable did we choose to eliminate first? Did it matter? Not really, right? There's a good choice for X, Y, or Z. It didn't really matter. Jack suggests let's do Z's. That's fine with me. Which one of the three equations are we going to use as our eliminator equation for Z's? Hopefully you pick equation B. So we can do 2 times B plus A, or we can do negative 3 times B plus C. That'll eliminate the Z's in either of those two situations. So 2 times B and then A and then negative 3 times B So those are going to become my 2 new equations. D and E. Which variable do you want to eliminate then from D and E? X or Y? Y, okay. So what do we need to do to eliminate the Y's? Sure, let's make them both of the leading coefficients 30 and negative 30. So we'll do 10 times D plus 3 times E. Which is, numbers getting kind of big, but not that bad. 3 times 17 is negative 51. That's 39. Hold on 1 second. This should be positive 6. Jeepers creepers. That's better. Okay. It's like something's up. So that leaves me with 99 equals 99. So X equals 1. I can then plug that back into either equation D or E. I'm going to plug it into equation D. When I subtract 15 from both sides, I get negative 9. And I divide by negative 3, I get positive 3. And then lastly, I can take both of those two answers and plug them into either A, B, or C. For the sake of argument, I'm going to plug them into equation B. So 6 minus 6 gives me 0. So I have Z then just equals negative 2. So I'd write my final answer 1, 3, negative 2.